Now we're getting into proportions and variation. This is actually pretty simple. Proportion is when two ratios are equal. A is to A, big A is little b is to big B. That's how it's pronounced. A over little big A equals little b over big B. Now, if you have a proportion, an equation between ratios, you have three of the numbers, and you can find the fourth. So if A over big A equals B over little b over big B, then find little a, we transpose big A. Little a is B, big A over big B. Transposing the B, you get little b equals A, big B over big A. To find the big letters, big A and big B, first we turn these upside down, take the reciprocals. So instead of A over big A equals B over big B, it's big A over little a equals big B over little b. To find big A, you transpose little a and get big A equals big B, A over B. To find big B, transpose little b and get big B equals big A, B over A. If you have two similar triangles, that is to say triangles with equal angles, this angle equals this angle, this equals this, and this equals this, then their sides are in proportion. Sides A, B, and C, sides big A, big B, and big C. Little a is to big A, and little b is to big B, as little c is to big C. This is a three-way proportion. Who's M arrow? Oh, Emerald Pond, that's right. Here we have some equal triangles, a small tree and a cell tower being lit by the sun, same height in the sky. So these are similar triangles, and they're both, standing straight up. These are right angles, and the angle of the sun is the same. And the tree is 6 feet tall, and its shadow is 3 feet 9 inches. And here's a cell tower with a 75-foot shadow. How tall is it? Well, all right. Big H is the 75 feet, as 6 feet is the 3 foot 9 inches. It's 3 and 9/12 inches. Now, if you transpose a 75, H equals 75 times 6 over, this comes to 15/4. After a bit of arithmetic, it's 120 feet. So that's how tall the cell tower is. It's 120 feet tall. Now, here we have some pretty routine proportions, the algebra problems. X over 5 equals 15 over 25, 5x. We transpose the 5 and get 5 times 15 over 25, which reduces to x equals 3. Here we have 4 over y equals 6 over 27. Now, to get y in the numerator, we turn both of these upside down. We invert them, or reciprocate them. So instead of 4 over y, it's y over 4. Instead of 6 over 27, it's 27 over 6. So just basically turn this equation upside down. At this point, we solve y by transposing the 4. So y equals 4 times 27 over 6. After a small amount of work, that's y equals 18. Now, we're talking here about direct, inverse, and joint variation. Y varies directly as x if y equals a constant times x. K is called the constant of proportionality. The idea is that when x gets twice as big, so does y. Y varies inversely as x if y equals k divided by x. So if x gets twice as big, y gets half as big. Y equals kx, its graph is a straight line to the origin with slope of k. Y equals k over x is this hyperbola, k over x, going to infinity at 0, to 0 at infinity. If you have more than one variable, then you can vary jointly. Here, y varies directly as x and inversely as z. Now, directly as x, x is in the numerator, inversely as z, z is in the denominator, and of course, there's a constant of proportionality k. Y equals kx over z. So this is two variations, this joint variation. Here we have y varies directly as the cube of z, so kz cubed in the numerator, and inversely as the square of x divided by x squared, that's in the denominator. Y equals kx z cubed over x squared. It's joint variation. All right. Okay, an avocado problem. That should be, that's misspelled. how I misspelled that. Anyhow, 5 avocados cost how much if 3 avocados cost $1.98? Cost of 5 avocados is the 5 avocados, as $1.98 is the 3 avocados. Transpose of 5 avocados cost is $1.98 times 5 over 3. After some work, it's $3.30. The force on an object varies directly as its mass, gravitational force. Force on 5 kilograms is 49 newtons. What's the force on 12 kilograms? Now, I'm not sure the constant of proportionality puts this problem on Earth, but let that pass. Force equals G times M. G is the constant of proportionality. So G equals F over M. So in this case, the constant of proportionality is 49 newtons divided by 5 kilograms. So it's 49 fifths newtons per kilogram. Now, if you have a mass of 12 kilograms, the force is G times M, 49 fifths newtons per kilogram times 12 kilograms. So 49 times 12 over 5 newtons, kilograms cancel. And after a bit of small amount of arithmetic, that comes out to a force of 117.6 newtons. And here we have a bit of electrical engineering. The resistance of a wire is directly proportional to the wire's length. So twice as long a wire means twice the resistance. That's inversely proportional to the square of its diameter. The square of the diameter means it's that much more area. So twice the area is half the resistance. Twice the diameter is 1/4 the resistance. If the resistance is 1.2 ohms in an 80-foot long wire with a diameter 0.01 inches, what is the resistance of a 160-foot wire with a diameter of 0.04 inches? Okay, resistance equals K times L over D squared, length over the square of D. So solving for K, we transpose the D squared and the L. K equals resistance times D squared over length. From here, 11.2 ohms here, D squared, 0.01 squared here, divided by L, 80 here, 11.2 times 0.01 squared times 80. After some churning, it's 1.4 times 10 to the negative fifth. Okay, so resistance equals K, L over D squared. Okay, we found K. 1.4 times 10 to the negative fifth. All right, L is 160 here, diameter 0.04 here squared. And after some arithmetic, is 1.4 ohms. All right. What was that?